So, in the interest of splitting things up and keeping the videos short, I'm going to talk about the history of gravitation a little bit at the beginning here as its own little separate video. It's not something that's super important for you to know, so this is mostly just extra information about the topic. So, first, on the idea of gravitation, that there is something that causes things to be pulled towards the Earth, like when you drop an apple. This was known more or less for a very long time. Certainly the Greeks wrote about it, and they had their own ideas about what makes it happen. Those ideas were wrong. The Greeks kind of had this view that if it is beautiful in the mind, it must be truth in reality, and that's not always the case, so they had kind of a wrong idea about how forces work. It also explains why they were really good at mathematics, but their physics hasn't really survived to the modern era because it was wrong. If you want to know about Greeks who actually did experiments to verify things like this, the cult of Pythagoras was apparently one of the earliest sort of scientific method kind of things out there. Although our modern history of actual experimentation to verify what we think happens, a lot of the credit for that actually goes to Muslim scholars in like the 12 to 1500s or something like that. And presumably the influence they had through the Moor population in Spain, kind of propagating that into Europe. Of course, the modern history of investigation and experimentation is built well beyond that at this point, but it is sort of interesting how all of these things go back, and the Greeks weren't really that big on doing experimentation to verify their thinking. All right. So we kind of move forward from there, and we're going to jump quite a ways forward to the time of Galileo and people like Copernicus, and starting to have this notion that the Earth isn't the center of things, maybe it's the sun, and then specifically some of Galileo's experimentation where he was able to show that pretty much all objects near the Earth experience the same acceleration, which is a very interesting result, that it's not dependent on essentially the mass of the object, how much it feels like it weighs. It's really just a feature of kind of reality or the body of the Earth. So there was a lot of knowledge about what's going on, that something is tugging things towards the Earth, not really a notion necessarily that it's the Earth responsible for it. We come to the time of Newton, and there's actually quite a lot of discussion, and for the first time some very careful experimentation that's starting to show that any two masses actually experience a force in between them. You might be surprised to know that experiment was not run by Newton. It was run by Cavendish and Hooke and others. But there was a lot of discussion taking place about what was going on, and a realization that there's some sort of distance-dependent force between the objects that also depends on how much the objects physically weigh. And the equation for it really isn't necessarily Newton's own invention. It's sort of coming out of discussion of many scientists at the time. So why is it we end up calling this Newton's law of universal gravitation? Well, you've probably heard that apocryphal story of Newton looking out at apples, or maybe even sitting under a tree and getting hit on the head by an apple and realizing, oh, it's gravity that makes things fall. No, that's really an apocryphal story. More what happened is he saw this happening, and the connection eventually was made in his mind, wait a minute, what if this thing that's making the apples fall and making those masses get pulled to each other in these experiments is the same thing that makes the moon go around the Earth and the Earth go around the sun? He wasn't actually all that comfortable with gravitation as a force, simply because at the time all forces that were known required contact, and here all of a sudden we have this force that doesn't require contact. But still, he got on board with the idea and talked about, hey, this isn't just something that happens in the experimental frame of the laboratory, something you can do with a couple masses. It's happening between the Earth and anything on it, and the Earth and the moon, and the sun and the Earth, and everything in the universe. And for the first time, we really had an idea why it is that the planets dance their dance, why they go around the sun. Because it was a very mystical thing for a long time, and there was a lot of mysticism about circles, because the orbits of planets are mostly circular, or at least they look pretty circular until you really look carefully. So that kind of sets the stage for us to come in and talk about the equation for gravitation, and actually get some work done using the proper form of gravitation, which is not F equals mg. Sort of. You'll see as we go.